February 17th, 1944, 4:30 in the morning. 72 American fighter planes screamed out of the pre-dawn darkness at full throttle engines, howling like demons unleashed from hell, diving toward the most heavily fortified Japanese naval base in the entire Pacific Ocean. The pilots had one order: destroy everything. Bombs fell. Fuel depots erupted into walls of fire, visible 40 miles away. Japanese aircraft exploded on the ground before their pilots could even reach the cockpits. Anti-aircraft guns opened up in every direction, filling the sky with tracers, but it was already too late. In the first 12 minutes of Operation Hailstone, American fighters had turned 2 years of Japanese naval dominance into burning wreckage on a coral airstrip. By the time the sun fully rose over Truk Lagoon, the so-called Gibraltar of the Pacific, the fortress that no Allied force had dared to challenge for 2 years, was hemorrhaging fire oil and steel into the sea. 250 Japanese aircraft destroyed. 137,000 tons of shipping obliterated. 6 fleet oilers gone. 17 freighters gone. The submarine tenders the repair vessels the entire logistical backbone of Japan's Central Pacific strategy, all of it reduced to burning debris on the ocean floor. The admirals in Tokyo could not understand how it happened. How did the Americans get close enough? How did they sustain the attack for 2 full days without running out of fuel, without losing aircraft to attrition, without collapsing under the strain of combat operations so far from their nearest base? Pearl Harbor was nearly 4,000 miles away. There was no American base close enough to make this operation possible. There was no harbor, no airfield, no fuel depot anywhere near Truk that could support a force of this size and this ferocity. Except there was. And it had been built by a group of electricians, welders, pipe fitters, and bulldozer operators in exactly 46 days. This is the story of how a coral ring that Japan considered worthless trash became the most important piece of real estate in the Pacific War. And it begins with a man named Thomas Withers, a Navy commander sitting in a planning room in Pearl Harbor in the winter of 1944, staring at a chart of the Marshall Islands and telling his superiors something they thought was absolutely insane. To understand why what happened at Majuro was so extraordinary, you have to understand just how desperate the situation was in early 1944. The United States Navy had been fighting across the Pacific for 2 years. It had won at Midway. It had bled for 6 months at Guadalcanal. It had ground through the Gilbert Islands at Tarawa, paying in American lives for every 100 yards of coral. But every victory came with the same brutal constraint: distance. The Pacific Ocean is not a body of water. It is an incomprehensible expanse of nothing. Between Pearl Harbor and the Japanese home islands, there are nearly 4,000 miles of open sea, punctuated only by tiny clusters of coral atolls that offer no infrastructure, no fresh water, no fuel, no food. Nothing. Every time an American task force sailed west to strike a Japanese target, it burned through fuel at a rate that made every passing hour a strategic crisis. Carriers consumed oil by the tens of thousands of barrels per day. Destroyers, cruisers, battleships, all of them feeding on fuel reserves that could only be replenished at Pearl Harbor 4,000 miles behind them. The mathematics were merciless. Task Force 58, the most powerful carrier strike force ever assembled, was burning so much fuel that it could only sustain offensive operations for a few days before it had to turn around and sail all the way back to Hawaii to refuel, then sail all the way back to the front, then refuel again. The round trip ate 3 to 4 weeks every single time. 3 to 4 weeks during which Japanese engineers were fortifying the next island, the next atoll, the next airstrip. 3 to 4 weeks during which American momentum died on the vine. The Navy's logistics officers had been screaming about this problem since 1942. The solution everyone kept proposing was the same: build permanent bases on each captured island, install massive fuel depots on shore, construct proper docking facilities, and inch forward, one slow, expensive, years-long construction project at a time. The admirals at Pearl Harbor considered this the only rational approach. You couldn't run a war from nothing. You needed infrastructure. You needed stability. You needed time. Time was the one thing they did not have. By January 1944, Admiral Raymond Spruance, commanding the Fifth Fleet, had a new target on his map: the Marshall Islands. Operation Flintlock would push the American front line another 700 miles west of the Gilberts, deep into territory where no American base existed and no American logistics chain could reach. Spruance needed to seize the Marshalls. He needed to do it fast. And then he needed to keep moving west toward Truk, toward the Marianas, toward Japan itself, without stopping to build a conventional base that would take years to complete. And that is when a Navy commander named Thomas Withers walked into the planning room with a chart of Majuro Atoll and said something that made every senior officer in the room stare at him like he had lost his mind. He said, "We don't need to build a base on land. We build it on the water." Withers was not an admiral. He was not a famous face on the front page of any newspaper. He was a methodical, precise career naval officer who had spent years studying logistics, studying the problem of supplying a fleet across oceanic distances, and studying a particular kind of Japanese miscalculation that he believed the Americans were about to repeat. His background was submarines. He understood better than almost anyone else in the Navy what a tender ship could do, what a floating machine shop was capable of, what happened when you stopped waiting for shore infrastructure and brought the infrastructure with you to the water. His idea was not entirely new in theory. The Royal Navy had sent store ships with its fleets for centuries. But what Withers was proposing was something different, something systematic, something that had never been attempted at this scale in the entire history of naval warfare. Instead of building a base and then sending the fleet, you send specialized ships, oilers, submarine tenders, ammunition vessels, repair ships, hospital ships to a protected lagoon, and you make it a base the moment the anchor hits the bottom. The lagoon itself is the harbor. The ships are the dock. The water is the infrastructure. You need minimal construction on shore, just a runway for air cover, a water supply, a fuel pipeline, and roads to connect the islands. Everything else floats. The senior officers listened. Then they told him it was impossible. You could not run a fleet of hundreds of ships from an atoll with no existing port, no fuel depot, no freshwater supply, no runway capable of handling modern aircraft. It was logistically incoherent. It was strategically reckless. It was, one admiral reportedly said, the kind of idea that sounds brilliant until the moment it fails catastrophically and gets 10,000 men killed. Withers did not back down. He had found his lagoon. He pulled out the charts of Majuro and walked them through the numbers. 25 miles long, 4 to 5 miles wide through the navigable center. Depths of 150 to 210 feet in the central basin. Almost no coral heads to obstruct navigation. A channel entrance at Kalalan Pass, deep enough for aircraft carriers and battleships from day one, no dredging required. 114 square miles of protected anchorage. It was not just a lagoon. It was the most perfect natural harbor in the entire Central Pacific, and the Japanese had abandoned it because they thought it was worthless. That, Withers argued, was the greatest strategic mistake Japan had made in the entire war. And the United States was going to use it to drive a knife straight through the heart of their Pacific Empire. The decision came down from Spruance himself. Majuro would be seized simultaneously with Kwajalein on January 31, 1944. And the moment it was secured, the 100th Naval Construction Battalion would go ashore and do something that had never been done before in military history. They would build a fully operational forward naval base in a matter of weeks on a piece of coral that had no infrastructure whatsoever. A base capable of fueling, arming, repairing, and provisioning the most powerful carrier force ever assembled. A base that would extend the strategic reach of American naval power by more than 1,300 miles overnight. The Seabees, the Naval Construction Battalions. They were not soldiers in the conventional sense. They were welders from Chicago, pipefitters from Pittsburgh, heavy equipment operators from Texas, electricians from California, carpenters who had spent their careers building skyscrapers and bridges, and had now been handed rifles and told to do the same work under enemy fire. The average Seabee was in his mid-30s. He had a decade of professional trade experience behind him. He could read a civil engineering plan, operate a D8 bulldozer in the dark, repair a diesel engine with improvised parts, and if the perimeter collapsed, pick up a weapon and hold the line. Their motto was 3 words: we build, we fight. And by the winter of 1944, they had already proven at Guadalcanal and Tarawa that they meant every syllable of it. On January 31st, 1944, reconnaissance Marines came ashore at Majuro expecting a fight. Japanese intelligence had suggested a garrison. What they found instead was a single Imperial Japanese Navy warrant officer who had been left behind as a caretaker with no orders to resist and no means to do so. He walked out of the tree line and surrendered without a word. The Japanese High Command had written Majuro off as strategically irrelevant. No deep-water pier worth defending. No airfield worth protecting. Just coral and lagoon and trade wind. The next morning, February 1st, 1944, the 100th Naval Construction Battalion hit the beach. Their landing craft scraped across a coral shore that had never seen war. No shell craters. No bodies. No burning palm trees. Just the low hum of the trade wind and the crash of breakers on the outer reef. And ahead of them, stretching 25 miles from one end of the horizon to the other, the most magnificent natural harbor any of them had ever seen. The equipment came ashore in a continuous stream. Bulldozers, compressors, pontoon sections, miles of pipe, crates of tools and hardware stacked 10 feet high on the beach. The men were already doing the math that the admirals had told them was impossible. Runway on coral, fresh water from the sea, a floating city for 200 warships. In weeks. They had no idea whether it could be done. They knew only that Task Force 58 was burning fuel somewhere nearby at a rate that made every passing day a strategic emergency. Truck was waiting. The Marianas were waiting. Japan was waiting. And 46 days from this morning, those 72 fighters would scream out of the pre-dawn darkness and set the Pacific War on fire. But before any of that could happen, these men had to solve 3 engineering problems that every expert in the Navy had quietly assumed were unsolvable on this kind of timeline, on this kind of island, with this kind of deadline hanging over their heads like an axe. The first problem would take every ounce of ingenuity they had. The second problem would push their equipment to the absolute limit of what machines can endure. And the third problem, the one nobody had even fully thought through yet, would turn out to be the invention that changed the entire character of the Pacific War. What they did in the next 46 days would not just build a base. It would rewrite the rules of what an army of tradesmen could accomplish when the fate of a campaign rested entirely on their shoulders. 46 days. That was all the time the 100th Naval Construction Battalion had to turn a coral ring that Japan had abandoned as worthless into a fully operational forward naval base, capable of supporting the most powerful carrier strike force in history. They landed on February 1st, 1944, with bulldozers' pipe sections and enough raw determination to move a reef. They had no fresh water, no runway, no fuel depot, no harbor infrastructure of any kind. And Task Force 58 was burning oil somewhere nearby at a rate that turned every sunrise into a countdown. By the end of Part 1, the Seabees were ashore. Their equipment was rolling, and the impossible clock had started ticking. But what nobody had told the men of the 100th Battalion, what the planning documents had quietly glossed over, was the single engineering problem that could collapse the entire operation before it ever produced a single combat sortie. The runway. Not the concept of a runway, not the location of a runway. The specific technical materials science problem of building an airstrip on a surface that was never designed to hold one. Because coral raw, unprocessed reef coral does not behave like dirt. It does not behave like gravel. It does not behave like anything in the engineering manuals that most of these men had trained on back in the United States. It fractures differently. It drains differently. It compacts differently. And when you roll 50,000 pounds of loaded bomber across it at 90 miles per hour, It fails in ways that can kill a pilot and destroy an aircraft worth more than most of the men on board would earn in their entire lifetimes. Commander Harold Titus had been fighting this argument since before the fleet left Pearl Harbor. Titus was the 100th Battalion's executive officer, a civil engineer from Ohio, who had spent 12 years building roads and bridges before the Navy handed him a uniform and a problem that had no precedent in any textbook ever written. He was 38 years old. He had the hands of a man who had operated heavy equipment personally and the eyes of someone who had watched concrete fail under loads it was never rated to carry. And in January 1944, sitting in a briefing room aboard a transport ship somewhere east of the Marshalls, he had stood up in front of the senior logistics staff and told them directly that the planned construction timeline for Majuro's primary runway was going to get pilots killed. The man sitting across from him was Rear Admiral Richmond Kelly Turner, commanding the amphibious forces of the Central Pacific. Turner was not a man who entertained doubt gracefully. He had commanded the Guadalcanal landings. He had watched the Navy bleed at Tarawa. He had been running amphibious operations in impossible conditions for 2 years, and he had developed an absolute intolerance for what he privately called engineering theater, which was his term for technical officers who used complexity as a reason to slow down timelines that the campaign could not afford to slow down. Turner looked at Titus across the table and said, "You have 73 days from first landing to operational runway. Those are not suggestions. They are operational requirements driven by carrier fuel states that I cannot change and will not negotiate." Titus did not flinch. "Admiral, the coral processing procedure we're being asked to use was validated at Tarawa on a strip 1/3 the length of what Majuro requires. We are talking about 5,800 feet of runway surface that has to carry PB-4Y Liberators at maximum gross weight. If we rush the compaction phase, if we skip a single wet rolling cycle because someone is watching a calendar instead of a moisture gauge, we will have surface failures within the first 2 weeks of operations, craters in the runway, aircraft nose-over incidents, dead pilots." Turner was quiet for 4 seconds. Then he said, "Fix it." That was the entire conversation. No additional resources, no timeline extension, no acknowledgement that the problem Titus had just described was real. Just 2 words and a dismissal: fix it. Titus walked out of that briefing room with the kind of clarity that only comes from understanding that you have been handed a problem and told that failure is not an option, and that the person telling you this does not fully understand why failure is possible. He had one advantage that Turner did not appreciate. He had Frank Denfeld. Lieutenant Commander Frank Denfeld was not famous. He would never be famous. He was a materials engineer from the Naval Facilities Engineering Command, who had spent the previous 18 months doing something that nobody else in the Pacific Theater had done with any systematic rigor. He had been studying coral, not as a geological curiosity, as a construction material. He had processed samples from Tarawa, from Macon, from half a dozen atolls across the Gilberts, measuring compressive strength at different moisture contents, tracking how different crushing methods affected surface density, recording how wet-rolled coral behaved under repeated heavy loads over time. He had an entire filing cabinet full of data that Turner's staff had never read, and that most construction battalion commanders considered theoretical noise. Denfeld's conclusion was specific and actionable. Crushed coral processed through a jaw crusher to a uniform aggregate size, laid in lifts no deeper than 6 inches, compacted with a minimum of 3 passes from a weighted roller at optimal moisture content, produced a runway surface with a California bearing ratio high enough to support any aircraft in the American inventory indefinitely. But every shortcut in that process created an exponential increase in surface failure probability. The wet rolling cycle was not optional. The lift depth was not negotiable. The aggregate uniformity was not a preference. They were the difference between a runway and a trap. Titus found Denfeld aboard a supply ship 3 days before landing. He spent 4 hours going through the data. Then he went back to his battalion commanders and told them that the construction sequence for Dollop Island's runway was going to follow Denfeld's protocol exactly, and that any officer who cut a corner in the compaction process to meet an intermediate schedule milestone would answer to him personally. The morning of February 3rd, 1944, 2 days after landing, the equipment was ashore. The reef was alive with the sound of machinery. Jaw crushers were running at the northern end of Dollop Island, reducing raw coral to aggregate. Graders were clearing the line of the existing Japanese strip, which was technically 5,800 feet long, and practically useless, its surface so poorly finished that even light aircraft had damaged their landing gear on it. Titus stood at the center line of the runway with a moisture gauge in his hand and a stopwatch around his neck, and watched his men work with the specific intensity of people who understood that the entire Pacific campaign was watching the same clock they were. The first lift went down on February 5th. 6 inches of crushed aggregate graded to a uniform surface, wetted to precise specification, and then the rollers came through. Once, twice, 3 times. The coral compacted visibly under each pass, the surface darkening as moisture was driven out, the aggregate locking into a matrix that started behaving less like loose gravel and more like a cohesive structural surface. Denfeld walked the line after each rolling cycle with a penetrometer, pushing its probe into the surface and reading the resistance number. He was looking for a specific value. He got it by the 3rd pass consistently. By February 20th, 6 lifts were down. The surface was building depth and density simultaneously. The men were working in shifts around the clock, equipment operators rotating every 4 hours in the tropical heat graders, running until their hydraulic lines cracked and being repaired on-site by mechanics who had learned to improvise under time pressure that would have been considered completely unreasonable in any civilian construction context. There were 12 breakdowns in the first 3 weeks. All 12 were fixed without stopping the work for more than 2 hours. On March 12th, Harold Titus walked the full length of the primary runway surface with Frank Denfeld and a penetrometer and a set of bearing capacity calculations and made a decision. He called his radio operator and sent a message to the fleet. The runway was ready for limited operations. The first aircraft landed on March 15th, a PB-4Y Liberator patrol bomber. Maximum gross weight, full fuel load. The pilot touched down at the threshold and rolled the full length of the strip without a single surface anomaly. No cracking, no cratering, no surface displacement of any kind. Denfeld was standing at the midpoint of the runway with his penetrometer, and when the Liberator rolled past him at 60 miles per hour, he looked down at his instrument and then looked up and allowed himself for the first time in 3 weeks to exhale completely. Titus sent a second message to fleet. Full operations by April 15th. Confirmed. By April 15th, the runway was handling round-the-clock traffic. Patrol bombers, cargo aircraft, fighter replacements for the carrier air groups, all of it flowing through a strip of compressed coral on an atoll that had been a Japanese discard pile 11 weeks earlier. The surface held. Every bearing capacity reading Denfeld took over the following months matched his projections within acceptable tolerances. Not one aircraft was lost to runway failure. Not one. The numbers told the story with complete finality. Before Majuro Task Force 58 required a round trip to Pearl Harbor between every major offensive operation. 4,000 miles, 3 to 4 weeks. Every time. With Majuro operational, that transit disappeared entirely. The strategic radius of American naval power expanded by 1,300 miles overnight. Carrier fuel states that had previously dictated operational pauses now permitted continuous pressure on Japanese positions across the entire Central Pacific. And the Japanese were starting to notice. The American strikes were coming faster than their intelligence models predicted. The gaps between operations that their garrison commanders had learned to rely on for resupply and reinforcement were closing with a speed that made no logistical sense given the distances involved. Something had changed in the American supply chain, something fundamental, something that their analysts could not yet explain. What they did not know was that a civil engineer from Ohio and a materials specialist with a filing cabinet full of coral data had solved a problem that every expert in the Navy had quietly assumed was unsolvable on this timeline. But solving the runway was only the first problem. The second problem, the freshwater crisis that was already threatening to shut down the entire base population within days, was about to demand a solution so unconventional that even Titus thought it sounded like science fiction when he first heard it proposed. And the man proposing it was not an engineer. He was a cook. The 100th Naval Construction Battalion landed on February 1, 1944, with nothing but coral equipment and a deadline that should have been impossible. They solved the runway problem with crushed coral and precision compaction. They solved the freshwater problem when a Navy cook named Petty Officer Second Class Raymond Kowalski walked into Harold Titus's command tent and suggested boiling the ocean, which was essentially what the distillation units the Seabees then installed proceeded to do, producing 50,000 gallons of fresh water per day from nothing but seawater and heat. The base was alive. Task Force 58 was refueling and rearming in Majuro Lagoon. 200 ships sat at anchor, where 2 months earlier there had been nothing but trade wind and coral. But in Tokyo, Japanese intelligence analysts were staring at something that terrified them. And the question was no longer whether Majuro would work. The question was whether it could survive what was coming next. The Japanese Imperial General Headquarters received its first clear signal that something fundamental had changed in American logistics capability in late February 1944. The timeline was wrong. The carrier strikes were coming too fast. After Operation Flintlock secured Kwajalein, their analysts had calculated a minimum 6-week window before Task Force 58 could mount another major offensive operation based on the known transit time from Pearl Harbor and the fuel consumption rates of American fleet units. The strikes on Saipan and Tinian came in 11 days. 11 days, not 6 weeks. 11 days. Admiral Minechi Koga, commanding the Japanese combined fleet from his flagship Musashi, convened an emergency staff conference at Truk on February 10, 1944. His intelligence officer placed a single chart on the table. It showed the Marshall Islands. It showed Majuro. It showed the sailing distances. And it showed a number that made every officer in the room go quiet. 1,300 miles. The Americans had moved their effective operational radius 1,300 miles closer to Japan in under 6 weeks. Not through a conventional base construction program, not through a months-long infrastructure project, through something that Japanese doctrine had no category for: a floating city. A mobile logistics system that could be transplanted to any captured lagoon and made operational in days rather than years. Koga's response was immediate. He ordered Truk evacuated of all capital ships, battleships, Musashi and Yamato. The heavy cruisers, the fleet carriers, all of them departed for Palau within 72 hours of the intelligence assessment being confirmed. He was right to do it. He was also too late to save everything else. What remained at Truk when the capital ships left was not nothing. It was the entire logistical infrastructure of Japan's Central Pacific Garrison Network. 41 merchant vessels, 6 fleet oilers carrying the fuel reserves for a dozen island garrisons, submarine tenders, repair ships, ammunition transports. The supply chain that kept tens of thousands of Japanese soldiers on islands from the Carolines to the Marianas, fed, armed, and equipped, all of it sitting in Truk Lagoon because Koga had run out of time to move it. Back at Majuro, Titus was watching his water distillation units run a concerning efficiency drop in the second week of February. 3 of the 21 stills had developed scale buildup in their heat exchange coils faster than the maintenance schedule anticipated. The production rate dropped from 50,000 gallons per day to 38,000. For a base population that had grown to several thousand men, plus the rotating crews of 200 ships, 38,000 gallons per day was below the safety margin. Titus put every available maintenance crew on the still problem and simultaneously imposed strict water rationing across all non-essential functions. The fleet got priority. The men got what was left. Senior officers from the fleet logistics staff came ashore on February 13th and looked at the distillation numbers and told Titus formally that if production was not back above 45,000 gallons within 72 hours, they would have to consider rotating part of the fleet anchorage back toward Pearl to reduce the demand load on the base water system. Titus looked at them and said nothing for a moment. Then he asked for the maintenance parts manifest from the latest supply ship. He found the replacement coil sections he needed listed as low-priority cargo, buried under aviation spare parts and ammunition. He had them pulled from the hold overnight and installed by morning. Production was at 52,000 gallons per day by February 15th. The fleet stayed. Nobody filed a commendation for Harold Titus over that particular crisis. Nobody wrote about it in any naval history. It was the kind of problem that gets solved quietly in the background, while history is being made loudly somewhere else. And on February 17, 1944, history was very loud indeed. Pre-dawn, 0430 hours, 72 F-6F, Hellcat fighters launched from the decks of Task Force 58's carriers into absolute darkness, 90 nautical miles northeast of Atoll. Every one of those aircraft had been fueled at Majuro. Every pilot had rested at Majuro. Every replacement aircraft in the air groups had been delivered through Majuro's second runway on Uliga Island. The entire strike force existed in its current state of readiness because of 46 days of construction work on a coral atoll that Japan had thrown away. The Hellcats went in low. Truck's radar was ineffective at low altitude. The first Japanese ground controller to understand what was happening had approximately 40 seconds between his initial radar contact and the moment American fighters were over the 4 main airfields at full attack speed. He used those 40 seconds to pick up a telephone. The telephone network was overwhelmed before the call connected. Hellcats over Eaton Island Airfield. Japanese aircraft lined up on the apron engines, cold pilots ashore. 50 caliber rounds walked down the flight line at 600 rounds per minute per gun. Aircraft erupted. Fuel fires started. Ground crews ran. More aircraft burning. Moved to Param Island. Same picture. Dablon Island. Same picture. Over 300 Japanese aircraft sat on the ground across Truk that morning. Roughly half of them operational. The fighter sweep shot down 31 in the air in the first 20 minutes and destroyed dozens more on the ground before their pilots could reach them. American losses in the opening sweep: 4 fighters. Lieutenant James Ramage had been tossing a medicine ball on Enterprise's flight deck when he watched the first launch go off into the darkness. He led Enterprise's second strike group at 08:58:12, Dauntless dive bombers with full bomb loads targeting the anchorage shipping that filled Truk Lagoon in dense concentrations. His formation crossed the outer reef at 14,000 feet anti-aircraft fire building in intensity below them. Black bursts dotting the sky at their altitude. Ramage picked his target. A fleet oiler fully loaded, sitting motionless at anchor. He pushed over into his attack dive. The altimeter unwound. 6,000 feet. 4,000. Release. He pulled hard and felt the aircraft respond, already climbing away as the bomb found its target. The oiler erupted. Not a small fire. A catastrophic detonation as the full fuel cargo ignited simultaneously, a column of orange flame climbing 2,000 feet above the lagoon surface. 2 miles away, a second bomber in his group put its bomb into a freighter that broke in half and sank in under 4 minutes. Strike groups from Yorktown, Essex, and Bunker Hill were hitting the anchorage from multiple approach angles simultaneously. Anti-aircraft fire was intense, accurate in places the Japanese gunners experienced and determined. 3 American aircraft were lost to anti-aircraft fire over the 2-day operation. The exchange ratio was not close. Torpedo Squadron 10 flew the first radar-assisted night torpedo attack in carrier aviation history on the evening of February 17th, hunting by instrument through total darkness, putting Mark 13 torpedoes into Japanese shipping that never saw them coming. By the time the sun rose on February 18th, the anchorage that had been Japan's logistical backbone for the Central Pacific was burning from one end to the other. Final count when Task Force 58 recovered its aircraft and turned east toward Majuro. 250 Japanese aircraft destroyed. 6 fleet oilers gone. 17 freighters totaling 137,000 tons of shipping obliterated. Submarine tenders, repair vessels, ammunition transports, all of it sunk or burning. The garrison networks across the Carolines and Marianas that had depended on Truk's supply chain were now cut off with no replacement pipeline in sight. Japanese logistics in the Central Pacific had not been degraded. They had been functionally destroyed in 48 hours. Every sortie of those 2 days traced back to Majuro. Every gallon of aviation fuel. Every replacement aircraft. Every rested pilot. Every armed and loaded bomb rack. The operational mathematics were absolute. Without the forward base the Seabees had built in 46 days, Task Force 58 would have needed to operate from Pearl Harbor. The round trip would have consumed 3 weeks. Operation Hailstone would have happened in April at the earliest, if at all. The Japanese capital ships that Koga pulled out of Truk would still have escaped, but the logistical infrastructure would have had weeks to disperse. The strike would have hit a far less valuable target. The Central Pacific campaign would have slowed by months. Instead, Truk was finished as a strategic base forever. The Japanese never returned it to operational status. The garrison islands it had supplied began their slow starvation. And the pattern that the Seabees had invented at Majuro, capture the lagoon, install the floating base strike before the enemy can respond, was already being written into Navy doctrine as the operational template for everything that followed. Admiral Spruance sent a message to Majuro on February 19th. It read, "The work done here made this possible." Titus pinned it to the wall of his command tent next to the moisture gauge readings from the runway compaction phase and the water production logs from the distillation crisis. Then he walked outside and looked at the lagoon, where 200 ships sat at anchor in water that was the color of glacial ice shot through with jade, and he thought about the next problem. There was always a next problem. But the question nobody was asking yet, the question that would define what Majuro actually meant in the long arc of the war, was not about engineering. It was about the men who had built it. What happened to them when the campaign moved west? What happened to the doctrine they had invented under fire? What happened to the idea itself? The idea that a nation that could industrialize its engineering could project power anywhere on Earth from nothing in weeks. That answer was still being written. And the last chapter was the one that nobody expected. From a coral ring that Japan threw away to the operational engine that drove the most powerful naval campaign in human history. The 100th Naval Construction Battalion landed on February 1, 1944, with nothing but equipment expertise and a deadline that every expert said was impossible. They built a runway in 73 days on a material nobody had ever used at that scale. They distilled 50,000 gallons of drinking water from the ocean every single day. They created a floating city for 200 warships in a lagoon that the Imperial Japanese Navy had abandoned as strategically worthless. And from that base, Task Force 58 launched Operation Hailstone and destroyed the logistical backbone of Japan's entire Central Pacific Empire in 48 hours. But there is one question that the operational histories and the battle statistics never fully answer. What happened to the men who built it? What happened to Harold Titus, Frank Denfeld, and the 1,000 tradesmen who turned an impossible timeline into a functioning forward naval base? Because their story has a final chapter, and it is the one that matters most. Harold Titus was promoted to full commander in June 1944, 4 months after the 100th Battalion landed at Majuro. The promotion was noted in his service record with a single line. No ceremony, no press coverage, no photograph in any newspaper. The Pacific War was generating heroes at a rate that overwhelmed the machinery of public recognition, and the heroes it recognized most readily were the ones who flew aircraft or commanded ships or led assault troops across defended beaches. The men who built the beaches, who laid the fuel lines and graded the runways and solved the engineering problems that made every assault possible, occupied a different category in the public imagination: essential, invisible, Titus remained at Majuro through July 1944, overseeing the transition from the 100th Battalion to the 60th, which arrived to relieve the original construction force and expand the base infrastructure to support the Marianas Campaign. He wrote a detailed after-action report covering every engineering decision the 100th had made, every problem they had encountered, every solution they had improvised under pressure. The report ran to 240 pages. It was classified immediately and distributed to every construction battalion commander in the Pacific Theater. It became, in effect, the foundational manual for every forward base the Navy built in the final year of the war. Frank Denfeld, the materials engineer whose coral compaction data had made the runway possible, was reassigned to the Naval Facilities Engineering Command in Washington in August 1944. He spent the rest of the war writing technical specifications for construction battalion operations, translating what he had learned at Majuro into standardized procedures that could be taught to engineers who had never seen a Pacific atoll. He never returned to the Pacific. He never commanded troops or led men under fire. He worked in an office building in Washington and produced documents that most people would find completely unreadable. And those documents saved lives in numbers that are genuinely impossible to calculate, because the bases built according to his specifications supported operations that ended the war months earlier than they would have ended otherwise. Titus went home to Ohio in October 1945. He drove back to the house he had left in 1942. His wife had kept a garden going through the entire war. He walked around the perimeter of the yard that first evening, looking at the flower beds, and his daughter, who was 7 years old, asked him what he had done in the war. He told her he had built some roads. She accepted this completely and went back inside. He stood in the yard for a long time after that. He never wrote a memoir. He gave one interview to a local newspaper in 1947 that ran on page 11. He returned to civil engineering and spent the next 20 years building bridges and highways across the state of Ohio, applying the same precision and the same intolerance for shortcuts that had made the Majuro runway hold under maximum load. He died in 1981. His obituary mentioned his military service in the third paragraph. But the legacy that Harold Titus never discussed in any newspaper interview was already reshaping the world while he was building Ohio highways. The doctrine invented at Majuro, which the Navy formally codified as the mobile base concept and assigned to Service Squadron 10 as its operational template, did not die with the Pacific War. It evolved. It metastasized. It became the foundational principle of American power projection for the rest of the 20th century and into the 21st. The Korean War in 1950 saw construction battalions deploy the Majuro template at Pohang and Incheon, within weeks of the initial landings, establishing forward logistics bases from minimal infrastructure on timelines that would have been considered physically impossible by the military engineers of any previous generation. The lessons about coral compaction that Denfeld had codified were adapted for different soil types, different climates, different materials, but the underlying principle remained identical. Find the protected water, bring the specialized ships, build the minimum shore infrastructure, make the base operational before the enemy can respond. Vietnam saw the same template applied at Da Nang Chulai and a dozen smaller installations where Seabees battalions built operational airfields and port facilities at speeds that conventional military engineering doctrine said were unachievable. The mobile construction battalions that operated in Vietnam traced their institutional lineage directly to the 1942 authorization that had created the original CBS, and their field procedures cited documents that Frank Denfeld had written in a Washington office building in 1944 and 1945. The floating logistics concept that Titus's base had pioneered reached its most sophisticated expression in the maritime prepositioning force that the United States Navy operates today, a permanent fleet of specialized ships preloaded with equipment and supplies that can be sailed to any point on the globe and combined with airlifted personnel to create a fully equipped military force within days of a crisis emerging. The specific ships are different. The technology is different. The scale is different. The principle is identical to what Raymond Spruance and Thomas Withers sketched on a chart of Majuro Atoll in January 1944. You do not wait for the infrastructure to arrive. The infrastructure travels with you. The base is wherever the ships are. The total accounting of what this doctrine produced is staggering in its scale. The 7 forward bases built in the Pacific between February 1944 and September 1945, using the Majuro template, supported operations that historians estimate shortened the Pacific War by a minimum of 12 to 18 months. The casualty projections for a conventional island-by-island campaign prosecuted on pre-Majuro logistics timelines ran to hundreds of thousands of American dead, and that number does not include the Japanese military and civilian casualties that would have accumulated through 18 additional months of conventional warfare. The number of lives the Seabees saved by making the mobile base concept work at Majuro is not a number that fits comfortably on a monument or in an obituary. It is simply very large. The bravest idea in the Majuro story was not the coral runway. It was not the distillation stills. It was not the pontoon pier or the causeway network or the aviation fuel depot on Big Edge Island. The bravest idea was the one that Withers and Spruance committed to when they decided that the United States would not wait for perfect conditions, would not wait for conventional infrastructure, would not wait for the enemy to finish fortifying the next island while American logistics caught up. They decided to move faster than the problem, and the men who executed that decision were electricians and welders and pipe fitters from Ohio and Texas and California who had been handed uniforms and told that the outcome of the largest naval war in human history depended on their ability to do in weeks what normally took years. They did it. They did it without complaint, significant enough to reach any historical record. They did it in tropical heat on a diet that the Navy's nutritionists would not have considered adequate, with equipment that broke constantly and was repaired on-site with whatever parts were available. They did it because they understood their trades deeply enough to improvise within them, and because the alternative was unacceptable. Now here is the detail that almost nobody knows. The Japanese warrant officer who surrendered Majuro on January 31, 1944. The single man left behind as a caretaker for an atoll. His commanders considered worthless, was held as a prisoner of war through the remainder of the conflict. After the Japanese surrender in September 1945, he was repatriated to Japan. His name was Warrant Officer Yoshio Nakamura. In 1968, a retired American naval historian named Samuel Eliot Morrison was corresponding with former Japanese naval officers as part of a research project on Pacific War logistics. Nakamura, then in his late 50s and working as a schoolteacher in Osaka, wrote Morrison a letter. In the letter, he described the morning of February 1, 1944, watching the American landing craft come ashore, watching the bulldozers roll onto the beach, watching the construction equipment multiply across the coral with a speed and organization that he said he found genuinely incomprehensible. He wrote that he had stood at the edge of the tree line and watched and thought that he was seeing something that his country did not have the ability to do. Not the machines, not the weapons, the system. The organized, purposeful, unstoppable system of men who knew exactly what they were doing and why, and did not stop doing it from the moment they arrived. He had been told that Majuro was worthless. Standing there watching the Seabees work, he understood for the first time that the war was already decided. Not by the carriers, or the fighters, or the bombs. By the men with the bulldozers. From a coral ring that Japan considered trash, to the operational center of the most powerful naval campaign ever fought, Harold Titus, and the men of the 100th Naval Construction Battalion, proved something that military history has confirmed in every conflict since. The side that can move its logistics further faster and more reliably than its opponent holds an advantage that no weapon system can overcome. The Seabees built Majuro in 46 days, and from that base, American naval power reached out 1,300 miles further than Japan thought possible, and destroyed the logistical spine of their entire Pacific strategy. 325,000 men served in the naval construction battalions across the Pacific War. Most of them came home to lives that newspapers never covered and obituaries that ran on page 11. If you want to understand how America won the Pacific War, do not start with the carriers. Start with the men who built the coral roads those carriers depended on. Because the atoll that Japan laughed at became the road to Tokyo. And the men who built that road were electricians, welders, pipe fitters, and carpenters who simply refused to accept that the impossible had any business being impossible.